let's move on to our next speaker, and that's Benjamin Law, who spoke to us a few months ago. So he's coming back with an update to his imaging, solar and ISS photography. Go ahead, Benjamin.
Hi, everybody. First, I would like to thank RSC Toronto Centre for inviting me to share with you this evening about taking picture of our own star and ISS. So I'm Benjamin, sharing with you here from Stouffville, Ontario, in a room with no AC. Yes, my AC broke since the end of May and it's not fixed yet. But anyways, astrophotography is only my hobby, and I'm not a professional photographer, but I hope through this evening I can share with you some of the photos. And also, just like every other hobby, we all may be at different stages in it. So feel free to connect with me through my social media account, which will be shown at the end of the presentation. Astrophotography is a very interesting hobby. Not a popular one, I would say, but a lot of people misunderstood what that actually is. When people are not involved in this hobby, they may think what astrophotography is all about, as you can see from this picture. Unlike daytime photography, you mostly take a picture and see what you get almost immediately. Astrophotography takes time, lots of time, especially in preparing and getting ready for the processing after each shot. I can categorize astrophotography into four main areas: wide field, deep sky, planetary, and solar. And each will take a different level of challenges if you want to take good photos. So generally speaking, for solar photography, depends on what you want to do. A simple white light filter may be good enough. If you want to do a little bit more fancy, you can get one of these solar telescopes. So here in this evening, I just focus on taking picture of the sun and the ISS. Just like taking picture of the night sky in other categories, the learning curve is always steep. It is easy to do it, but the fine-tuning of the data and the processing skills will take some practice. In any domain in astrophotography, I learned that there is always a solution for every problem. One of the biggest problems in astrophotography, in my experience, is light pollution. I live in Bordeaux 7 or 8 in northern part of GTA area. Here, my neighbor, I think they were trying to make it Bordeaux 99 randomly. My neighbor installed the pot lights around the entire house, of course, including the side facing my backyard. So solar imaging has the advantage that, of course, it is independent to light pollution, but it's heavily depending on the stability of the atmosphere, the so-called the seeing of the sky. The main gears I use for solar imaging, I have a used Lunt solar telescope a few years ago. And as I'm doing more and more community outreach with different community groups, I purchased the Solar Quest mount, which is a game changer. It has an internal GPS and that can track your time and location, and it automatically slew to the sun and center it in your eyepiece or camera within a minute after you turn it on. So it is a very, very good investment to me and for solar observation and imaging. The disadvantage for such mount is that Solar Quest is just like an altizimuth mount. It is subject for something called field rotation. That means the sun disk will slowly rotate in the field of the view, and field rotation, in my opinion, is not a big problem because the video length of a typical picture is about a minute, but it could be a problem for creating a time lapse that lasts for hours. So this can be corrected using different softwares in the processing stage, but it is really painful to do that by software. Sometimes if I want to be more fancy, I have more time, I will hook my solar scope with an equatorial mount. The advantage, of course, is having no field rotation, but it will take more time to set up, and tracking is not as good as the Solar Quest mount because alignment during the day is a little bit tricky and it's not quite accurate. Is there any solution for solar tracking? Yes. The Hinode Solar Guider, I just checked last night, it is nowhere in stock. It is pricey, but is hard to get. I discovered that there's a way to actually track the sun using the fire capture software, and I'm about to test it out. And if I have good results, I can come back and share that with you. So there's another possible combination using my existing setup. I have a Celestron 8-inch telescope with a smart light filter, with a white light filter in combination with an equatorial mount. And the white light filter is not able to give you any details of the solar prominences, but it is great for partial solar eclipse, satellite or planetary solar transitions like ISS, Venus, or Mercury solar transits. For example, this is what I took in 2012, the Venus solar transit. I used a white light filter for that. And this one, I used a white light filter for the Mercury transit in 2016. Yeah, but you don't see much features from any white light filter. With any setup of solar imaging, we would like to use a camera with a higher frame rate. With a higher frame rate, you can capture more frames in a shorter amount of time. The more frames you capture, the better result we can get after stacking. Think about it. If the target of what you're trying to shoot is static, which means it doesn't change at all, then the frame rate doesn't matter. Like galaxy, nebula, they don't change. But for planetary or solar imagings, they do change rapidly, especially when you zoom into the planets or the solar prominences. You'll find that they are moving rapidly. So a camera with high frame rate will usually get a better result. These are the two main cameras that are used for solar and ISS imaging. They are both mono cameras. Cameras from other manufacturers, I know they're also good. The focal length for my Lund solar telescope is about 500 millimeter. So to get a full solar disk, I would just need a camera with a bigger frame size and also have a higher frame rate. So the Apollo M Max will do a good job. If I need to zoom in a little bit more, I would use the Celestron 2X Barlow or the Teleview 3X Barlow to zoom in the special features. So how do we know what to expect in the field of view for your setup? We can plan ahead and see the expected frame using Astronomy.tools website. It's a very handy website for us to predict what to expect from the camera view. And I've tried various capturing software. Fire Capture is always my favorite. It works well with ASI or Player One camera because I have the fire capture for high-speed imaging for planets and solar, but other software is also as good as this one as long as we feel comfortable with it. Just like taking picture for the deep sky objects, we may want to take flat field or flat frames for solar imaging. Yet I have to admit that sometimes I'm just being lazy for not taking flat frames because I know there are some ways to correct the gradients in Photoshop, but the flat frames can definitely help making your final image more better without the gradients. And the gradients is very common in any solar telescope. I've tried two different ways to take flat frames for solar imaging. The first way is to put a thin Ziploc bag or just a clear plastic bag around the front lens. And the second method is called the defocusing blur. You simply move the focuser back for around half an inch, and then these two methods, I found they're pretty good as far as I know. Stacking is the way to make the final image more clear, more defined with better contrast, and with less digital noise. Many of you probably know about the software AutoStacker. It is great for stacking planetary and solar imaging. And there's a great tutorial bookmark right here. It is included in this slide. Here is a basic workflow in AutoStacker from my experience. You analyze, you draw the alignment points, you determine the percentage of frames to stack, and then you stack it and save it. It's pretty straightforward. Now, after stacking, we will need to sharpen the image. I've tried two various methods. Both are good. However, IMPPG, which is a software, I don't know why, it tends to give me pixelized results. But the Blur Exterminator, which is a paid software, is a plugin for PixInsight. I found it gives you a more promising result and more natural looking result. Now, I used mono camera for my solar imagings that I will show you in a moment, and they don't give any color. So if you want to give color images, you need to do some processing about it. Even though if you use a color camera, sometimes the colors are not what you want to have. So we need to do some manual colorization. With the setting of these individual channels, okay, so for red is 2.0, green is 0.8, blue is 0.2. You can do that in Photoshop or a free software called GIMP. You can actually create the golden red color for the sun disk or prominences. Here is a general workflow for my solar imaging. I just want to highlight that focusing is very important. By spending more time in focusing, you will have a better chance to get better image. Another thing is a saving parameter. I had an experience when I was trying to take time lapse of the sun over a few hours, and the recording stopped recording after 15 minutes because I didn't know that the saving parameter has suddenly moved back to the hard disk on my laptop instead on the portable hard drive that I'm supposed to use. So these videos take tremendous amounts of disk space. So if you want to get into solar imaging by taking image and videos of it, make sure you have enough disk space. I personally recommend getting one of these solid state drive, external drive for solar imaging or planetary imaging. So nowadays, the 1 terabyte external solid state drive is about $100 now. That's a pretty good deal. And I'm not promoting for Amazon, but the Amazon Prime Day is coming up. And I just saw that there's a 2 terabyte scan disk external hard drive for $165. I would say that's a pretty good deal. So from mono image to color image, you can actually do that processing using a software, GIMP, or Photoshop, equally good. This is a solar image on June 21st, 2023. You can see a lot of great solar prominences and different features around the sun disk. And the solar prominences, I hope it's not surprising to you, they are huge. And this one is especially, you can see that the solar prominences through a hydrogen alpha solar telescope. And for a white light telescope, you won't be able to see anything like that. Sometimes if you want to take the solar prominences clearly, you need higher exposure. That means your exposure, your shutter speed should be higher. So instead of having a way overexposed solar disk, you may want to cover the disk with a black circle or black part of the circle such that the viewing experience is more pleasant. So you see here, I can actually put the scales, right, in relation to the size of the sun, or put the Earth as a relative scale to show the size of the solar prominences. This can be done actually pretty easily. So what you need to do is to Google LUOSOL 3D. It is a Spanish program, but just Google it, download it, and you need to install Java for that. But once you play around with a few minutes, even though like me, I don't I don't like Spanish, you probably know how to work on this software very easily. So you just need to draw the size of the sun and then click a few buttons. All these scaling will be shown automatically on your picture. This one is a time lapse. It's composed of many video frames I took continuously for 80 minutes. You can see the solar prominences is actually moving pretty quickly. They're moving pretty quickly. So I forgot how many gigabytes of data I have used for this time lapse, but I save it on my external hard drive. And this solar prominences is huge. It is taken in March this year, 2024. You see the width of this solar prominences is almost the same distance as the Earth-Moon distance. This is humongous, humongous. A solar disk that I took in March this year, you can see there are lots of different features. The middle part right here is a solar flare, class X 1.1 solar flare. If you look at my picture through my social media account, you will find the details of exposure times and other settings and everything that I put on my social media account. Another, sorry for the spelling mistake, this is June 1st, 2024. And remember the huge solar geometric storm on May 10th that caused all the aurora borealis? It was caused by the sunspot AR 13664. And when it spins behind the sun and come back again, it has changed the name to AR 13697. This is a huge, and there's also a huge solar prominences in the middle of the sun. So this was the solar flare caused the May 10th geometrical storm. There's a different way to process the sun disk. Here's my first attempt, processing the sun in an inverted or negative manner. In the processing style, the sunspot appears in the sunspot and the solar prominences. They appear in white, and the solar flare appears in dark. Personally, I don't quite like this processing style, but I was just trying to give it a try. Oh, this is a beautiful solar loop prominences, very recent, on June 24th. You can see the size of the Earth compared to the size of the solar prominences. This is huge. This time lapse is working what scientists call the coronal rain. It's kind of bursting the sun's from hot plasma condenses in the strong magnetic field and falls back to the photosphere. I just got this photo this morning, July 3rd. There's a huge solar prominences observed today. So here's a setup that I used this morning, and I used a 60 seconds video, stack 50% of all the frames at 135 frames per second rate. Now, for solar imaging, of course, there are other special occasions, especially when the sun is blocked by the moon. This is the partial eclipse that I really like on 2021, June 10th. It has been a few years, and I did not use any filter for this picture. The sun, partially covered by the moon, just climbed up the horizon at around 5:30 that morning. And this is a partial eclipse in 2023. It's taken through my solar telescope during the one and only 30-second break during the eclipse. It was cloudy throughout the whole day, but I found a 30 seconds cloud break. Now, 2024 eclipse, I'm sure many of you have also seen that. Let me just show you the excitement of this total solar eclipse. The quality is not great because due to my poor cell phone camera, but you can feel the excitement right here. 40 seconds. Observe
image. 30 seconds, hands on camera filters.
Look at the sunset.
20, remove camera filters.
Whoa!
15,
Is it Venus?
10,
Venus was visible in the sky. Venus.
5, 4, 3, 2, 1. Glasses
Whoa!
off. Glasses off. Observe for planets and stars.
Wow! See the 360 sunset? I tell you, this is the most amazing celestial events we've ever witnessed. Last time in 2017, Pavel, I was also in Missouri. So we were very close to each other, but we didn't know each other back then. So I went to Missouri for the 2017 eclipse. I did not bring my kids because they were pretty young. And so this time, all my three kids were a little bit older. So me and another family originally planned going to Buffalo for the eclipse. We booked a hotel 18 months ahead of time. But on the Saturday before the eclipse, 2 days before the eclipse, we decided to go to Montreal instead of Buffalo. And it was a good decision. Even though the eclipse was behind the thin clouds, it was a very beautiful eclipse. It was even more beautiful than the one I saw in 2017, to be honest. This place, 30 minutes south of Montreal, is extremely beautiful. It is facing the lake, and you can observe the whole eclipse, with very, very good scenic view. And here are all the gears that I brought this time. So I observed the eclipse last time in 2017, but last time I flew there. So you probably understand that what we allowed it to bring on the plane is very limited. But this time it was a road trip, so I decided to bring everything. So these are all the gears that I brought for the eclipse this time. And here's a time lapse that I took using a webcam, a $30 webcam from Amazon. I have to say that I didn't need to worry about destroying the sensor because I just put a webcam facing the sun for a few hours. Because of the short focal length, the wide angle of the sun, it doesn't really destroy the sensor of the webcam at all. So even though it does, I was thinking it's okay. It's only a $30 webcam, but it does good. It does give me pretty good results. Here is a snapshot of one of the frames from the webcam that I used. You can see the total eclipse pretty well. You can see the boundary of the shadow thanks to the thin cloud. You can see the boundary of the shadow pretty clearly. And I learned from my first eclipse experience, I'm much more experienced and prepared this time. So on my camera, I used bracketed shot, bracketed exposure. So this video shows you the differences between 3 different exposures that are continuously taking during the 3.5 minutes eclipse. These are all without any filter, no filter. And this photo is actually taken by my daughter. She used her cell phone to take the eclipse photo, and it was beautiful. Now, I want to share with all of you some of my favorite eclipse photo from this year. Here is an HDR version showing the prominences as well as the corona. This time the sky was covered by thin clouds, but it is visually much more better than the last one, as we can see a lot of the pink color prominences around it. They were very clearly seen by eyes. By the way, there's no need to use any filter during totality. And here's a collage for different phases during the solar eclipse. Here's a diamond ring for the eclipse in 2024. And I composed this image from solar scope and the one during totality without any filter. And because my camera was working non-stop for the 3.5 minutes totality, this time I was able to capture the belly beats. These are actually created by the mountains on the moon when they just being covered by the sun. Part of the sunlight can pass through and show you this belly beats phenomena. And this one is showing you the beautiful solar prominences. There's no filter used in this picture. This one is a little bit interesting. I always say that for astrophotography is a combination of art and science. So I took the same moon in June 2023, and 10 months later, the same satellite, the same moon, covered the sun by almost the same amount. I love this composition. Here's another composition. It is my favorite eclipse photo. It is a composite photo showing all the visible solar prominences during the eclipse. So it is composed of 3 different photos between second contact and third contact. So you can see all the solar prominences around it. Now, this one shows you the ISS lunar transit. Do you see the ISS at the bottom video here? It may be too small, but if you pay attention to the bottom video, you see there's a dark spot just moving across the lunar disk. Now, ISS transit, it could be very, very small. And this is my most recent solar transit for ISS. On June 14th, I drove more than an hour to get into the center of the narrow shadow of ISS. See the ISS transit on the sun disk. It was exciting. So I was lucky. The sun was totally covered by clouds 5 seconds, literally 5 seconds after the transit was over. So, and this is the composite picture of all the ISS moving through the frame. And sorry, the sun looked very flat in this picture. So to predict exact moments for the lunar and solar eclipse, you probably know that there are many websites that can give you the prediction. And my personal favorite is the transitfinder.com. So for example, last week when I checked this website, I found that there is a lunar transit happening right in my backyard on July 11th. I was quite excited because it was just right inside my backyard. I didn't need to go anywhere. I can also use my bigger scope, which is not portable, for the lunar transit. But now when I checked that this morning, that path has moved 60 kilometers north from where I live. So it's okay, but now there's now a new transit close to where I live on July 13th instead. So the path of ISS does change and get updated from time to time. So I would say the prediction within 24 hours will be pretty accurate. What about zooming into ISS and taking some pictures of it? First, the challenge is that ISS is a moving target. With an altitude of 400 kilometers, with an orbital period around 90 minutes, does it mean that it is not possible to take a picture of the ISS close up when it moves in the sky? Well, actually, it is possible. And because of the Earth is not flat, it is a sphere, the distance between us as an observation point and ISS depends on the altitude of ISS in the sky. The more closer to above our head, the closer it will be. The closer it is, the bigger the image you can get. The closer it is, the faster it will move in the sky, however. So if we live anywhere above 51.6 geographic latitude, we know that ISS will not be directly over your head. So Toronto is 43 north, and from time to time, you'll find ISS will be kind of passing above your head. So how do we know? How do we know when and where we can see ISS fly over? There are two main websites. They do pretty good, reliable information. The first one is called heavens.above.com, and the second one is astropheric.com. These two websites, they both have mobile apps you can download on your phone. So as I said, ISS is a moving target. It is like, think about it, it's like taking a picture of a tree from a moving vehicle. On top of that, there's something called the seeing conditions, which is the atmospheric stability. It plays a big role in your image quality. And also ISS is extremely, extremely small. The largest angular size is about 63 arc seconds. When it is directly above your head, which is equivalent to 1/30th of the full moon, or 1/60th of your pinky when you stretch your arm out. It is extremely small. In the field of view of my setup is about 1/3 of the size of the full moon. Because it is moving so fast, we need a camera with high sensitivity and a high frame rate. This is what I use for capturing ISS. Because it is so small, to get some better details, I think I need a bigger scope. I am using a 14-inch tracking Dobsonian that I got once when it was on a big sale. And it's hooked up with a camera with a 3x bottle. So the field of view is extremely small. Because of the speed of ISS is moving across the sky is not uniform, I decided to track ISS by hand. By the way, I've seen images produced by 8-inch telescope. These are great images, but of course, the bigger the scope, the better in theory it will be. But I think 8 inches is the minimum for taking some close-up shot for ISS. Here you can see a video in normal speed, how fast ISS is actually moving across the sky. So on top of the tree, you see the bright dot. That was ISS in 2022. So it was moving pretty fast in the sky. This is like in regular speed. So I was holding my Dobsonian, trying to track it as good as possible. And that's how we shoot ISS. Now, tracking manually wasn't easy to begin with. But just like astrophotography in many areas, we learn from mistakes. One incident that I was checking the Heavens Above website, knowing that ISS will fly over at around 3 a.m. So I got everything set up and ready. So at 3 a.m., I got out in the backyard. My heart was pounding and ready to take my shot. However, I was like, where is it? It is supposed to be there at any moment. I thought the ISS changed the orbit, so I double checked the data. No, it's supposed to be there. So, and guess what? After a few minutes, I packed up and got back inside the house at around 3:30. I was a little bit upset and disappointed, but after looking at the website clearly, like what I've shown you here, I can see that, ISS were only illuminated near the horizon during that time. So for most part of the path of the ISS, it was in the Earth's shadow. I learned my lesson. And after that time, I had to look at the information very accurately. Now, alignment between the main scope and the finder scope is also very important because the field of view is extremely small. Originally, I used the finder scope that goes with the Jacksonian. Man, it drove me crazy because everything I see was left and right, top and bottom flipped. So later on, I replaced the finder scope with the Explorer Scientific Reflex Sight. It is just like a tarot, but it helped so much. Here's a setting of my setup for your reference. If you want to give it a try, remember to test out a specific setting that works for your setup. For the first time, if it doesn't work, we need to eliminate if the problem was related to bad seeing. So once you have very good seeing, this is a real test for the setting of your system. For the first attempt, it was interesting because my hand tracking skill was pretty bad. ISS were found only in 1% of the 18,000 frames that I captured, and only 7 frames were useful. And for the first timer, I had no clue what I was doing. I actually physically eyeball each frame one by one for 4 hours to identify useful frames. It was painful. As I said earlier, for every problem, there's always a solution. Now I know there's a free software, PIPP, that can automatically screen out, center, and crop the frame with ISS for me, all done by the software automatically. And here's the interface for PIPP. It is a free software. And this is the result of my first attempt in 2022. My second attempt was a little bit better. ISS appeared in 15% of the overall captured frame. And here are the results for my second attempt ever for ISS photography. Now, for those who wonder, this is the raw video of what produced by PIPP. So you see ISS is centered in the frame. For you, only those frames with ISS in it will be captured and cropped. You can see as it goes beyond the meridian line, it will change the orientation immediately. So I can say ISS imaging is also an example for lucky imaging. It is very depending on the atmospheric condition. All I need is just a few adjacent frames with good clarity. Again, it depends on the atmospheric condition, depends on the seeing so much. At that second when the frames are taken, especially when it is going above your head. If I'm lucky, and if I get good frames, I will proceed to processing the pictures. I will stack the frames using auto-stacker, sharpening using IMPPG, or touch-up using Photoshop or GIMP. This is the result of my ISS picture in 2022. You can see I get identified many of the features of the space station. And at the end of 2022, after 5 attempts, I was lucky to get a very good seeing that night, and I got a pretty decent picture for the ISS. This is my 7th attempt in 2023, last year. In my 12th attempt in 2023, you can see is to me, there's a good improvement in my images. My mono camera is sensitive and it has good frame rate and pixel size. Then I thought, well, can I make it in color? This got into huge debate on internet, on social media. So the debating topic after I post the picture was that, is that an authentic picture or not? If I colorize my picture using AI, I use the website to colorize it using artificial intelligence AI. Is it authentic or not? It generated a lot of discussion on internet. My standpoint to this is that I always disclose the fact that the colors it artificially add. The color is not the actual color of the ISS, but I obtained all other non-color data from my shots. And I thought, wait a second, this is my hobby. I'm not trying to produce any scientific research grade level picture for scientific use. So personally, I think colonizing it this way is acceptable to me. But of course, some people don't agree with that. This is my third attempt in this year, 2024, April 26th. And this is my last attempt, my sixth attempt this year in 2024. And I'm pretty happy with the result. You can see a lot of details on the space station. Now, can we track ISS mechanically? Yes and no. We can certainly track ISS using specific software. For example, this software works with Skywatcher mount to track satellites especially. This one is called PrevisSat. It tracks satellites as well. This is my personal recommendation. It's called the SkyTrack. They're all free software because this one works with me visually. I was able to see the satellite, whether it's ISS or other satellites, in the eyepiece visually. There was no problem. However, tracking satellite by software is tricky. It works fine visually. However, with the small field of view, and when the target is so small, if we want to track it accurately, I found that we need high-end tracking mounts. I simply just can't afford one of them. So, and for equatorial mounts, it will take a while for the mount to flip after the meridian line. By the time the mount is flipped, I bet the ISS is already gone. So considering all these factors, I decided to track it manually. They will give me a better chance of success because my Dobsonian, the tracking mount is not really that good in terms of tracking capacity. So lastly, I want to say that, I'm happy with the ISS picture that I took, but there are amazing pictures out there. This astrophotographer is located in the Middle East, and he tracked ISS using high-end mount and software. You can see this is amazing. Look at all these details Michael can produce. So again, thank you for letting me to share my pictures with you, and I'm more than happy to connect with all of you through my social media account. I would like to, and I'm looking forward to opportunities to learn and grow with each other through my social media accounts here. And thank you so much for having me this evening.
Benjamin, wow, you do amazing imaging. Amazing.
Thank you.
Those solar flares and prominences and the ISS images, really, really good work. Thank you so much for showing and sharing with us. And also thanks for putting together such a short, great presentation in a short amount of time, because it was only a week ago that I reached out to you and asked if you could present, and you said yes, and within a week you pulled together a very good presentation. Thank you for your hard work.
You're very welcome. Thank you.
Enyo, do we have any questions for Benjamin?
Yes, we do. Pardon me. We have several comments complimenting you on your images and on your experimenting. Very well done, and I'd like to add my own compliment to that. Two questions, both from Louis R. And I'll say them both together if I may. How much time do you take to prep for the photos? And his other question is, so are you taking photos of the ISS tomorrow morning? Supposed to be viewable from Toronto.
So first question, how much time do I prepare for it? Well, it depends. It depends. First of all, I constantly have different apps checking the weather forecast. And I usually, if I'm ready to take some pictures, I look at the forecast ahead of time and make sure that I can prepare for setting up everything ahead of time. But for solar imaging, it could be very spontaneous. So, for example, I showed you the solar prominences this morning. I had a website here. I can just check the real-time appearance of the solar disk, and I thought, wow, there's a big solar prominences. And I some time today, so I just set it up and take the shot. But for ISS, yes, I need to prepare a little bit more. For tomorrow morning, I'm not sure about the forecast for tomorrow morning yet, but it also depends on the altitude of the ISS, depends on like the position, because I'm kind of living in a city, so I'm surrounded by lots of houses and around my backyard. So I have to look at whether the ISS would be um, um, perfectly visible in my backyard, and also I have to check the seeing condition of the sky at that time. So if the prediction from my app saying that the seeing is not quite good, I would choose sleeping over that because I just can't spend every single night when it is above the sky and stay up late that night. Because for ISS photography, it is pretty tricky that you can always see that illuminated a few hours after sunset and maybe a couple of hours before sunrise. And any other time, ISS will be inside the Earth's shadow, and you won't be able to see that illuminated. So it is either shortly after sunset or in the middle of the night before sunrise. So I have to make sure that everything is good and promising before I can actually just bring my telescope out.
Very cool. Another question just came in from Darren. What was your biggest factor in your improvement? Camera settings or processing or atmospheric stability? And thanks for a great presentation.
Thank you. I would say atmospheric stability is only lucky. That's why I said it is a lucky imaging process. So, but when you have lucky imaging, I would say I try a lot. So let's say for ISS last year, 2023, I try at least 15 times. Whenever it's available, when the sky is kind of clear, I kind of practice the tracking, practice processing. There are many failures picture I did not show you there, but I think just this is why I like this hobby. It is difficult, it is challenging, but I know one thing for sure: if any one of us would like to try this, astrophotography, whatever in any domain, just keep trying, because I know that the more we attempt, the better we will do. Um, and I'm pretty sure about it. So by accumulating field experience in your processing, in your data taking process, we can always improve in this hobby.
Thank you. And that's all of our questions.
Great.
Thank you, and thanks again, Benjamin.
Thank you.